now let's look at De Morgan's laws. So the Morgan's laws are simply the laws that we use when we are simplifying some of the expression that we're going to look at in the next video probably. So these laws are very important to understand on this topic, as they are like the backbone of this whole topic. Okay, so there are some laws that are very important as we are going to be applying them, and as well as identities. Okay, so the most important laws that are commonly used, like in almost most of the questions, they are usually applied are associativity laws and distributive law. So let's look at them. So the first law, the associativity law, these are the most important laws that are usually used, like especially at our level. These two laws are what we'll be using. They are quite a lot, I think, more than even two, but these two are the ones that are usually used. So this law just simply states that suppose we have three sets where the first two sets, let's say set A and B, are united. Let's say A, U, B. The first two sets are united. Then the union of these two sets, the union of set A and B, is also united to the third set, which is C, is equal to a scenario where we have set A being united to a union of B and C. So it's saying that this expression E is equal to this expression E. If we were to plug in the values, we're still going to get the same answers. And then the second one is that the intersection of A and B, when it is intersected with the third set, which is C, is still equal to a scenario where we have set A being intersected with in an intersection of B and C. It will still give you same results. Don't worry, we are going to be proving them. And the second one, the distributive law. The distributive law, this one will be using it oftenly. This one is very important. Make sure that you understand it. So the distributive law, the first distributive law states that in a case where we have maybe, let's say, a set A being intersected with a union of B and C is equal to, this one is just in simple terms, whenever you have a scenario where you have three sets, where the set that is out here is intersected to a union of two different sets, you can kind of like expand. You can multiply throughout. How do you multiply? You're going to get A intersection, you multiply with B, A intersection, you multiply with C, then you separate by what is A, U. So for example, this one is going to be like this: A intersection times B is going to be A intersection B. You close in the parentheses, and then you're now going to separate by what is A. What is inside A? We have U. Now you're going to multiply this AN with the C. So meaning that we are going to have A intersection C. So this expression A and this expression A will still give you the same result. That's what it means. If you want, you can master them, but you should at least understand the logic behind it, so that you can just be able to recall them easily. You are going to see how we'll be applying them. So how do you apply this? So when you start simplifying, you are going to be in a scenario where you have this case, where you have three sets being represented in this form. What you should be doing is that if you find them in this form, you should be multiplying like this to leave them in this form. Then you continue to simplify by applying some identities that I'm going to teach you. So the second case of distributivity is a case where, let's say, we have a set. This time it's being united to two sets that are intersecting. Let's say B and C are now intersecting. The same concept, you multiply this throughout. So you're going to have A union B separated by what is A N, so that you don't need to master them. Just understand how they work, like the logic behind them. And you multiply this with C, you're going to have A union C. So while you'll be simplifying, if you find that it leaves you in this format and you are stuck, you should reverse it into this form. So you'll be just moving from this form to this form, from this form to this form. So if you are in a scenario where it is appearing like this, you can simply reverse. How do you reverse? By factorizing this, what is common in both at both sides. What is common A and what is common A. You are going to factorize this. You should go back to this form. I'm going to show you what I mean. So that's how it will be going. So now there are some also important identities that you should be aware of. And some of these are, let me say, identities. Say identities. So these identities, the first identity is A. What does this mean? This means that if you multiply this sign with a set that is already having another sign like this, they cancel. They are going to cancel each other. If you multiply a complement with a set that is a complement, it is going to cancel. So meaning, while you'll be simplifying, if you are in a case where you are stuck, maybe where when you reach somewhere where a case where maybe you have this scenario, you can simply take it to this form, and vice versa. The second identity is, let's say maybe we have two sets, A minus B. So in case where there is a difference of two sets, where we are subtracting two sets, it simply means that they are representing the elements that are found in this set but are not in this set. Okay, so now how do you represent this? This can also be represented like this: A intersected with the complement of B. So if you are in a case where you have been given a set difference, you can simply convert it to this form. There will be scenarios like that. So I'm going to solve some of the examples. You're going to see how it should be solved. So this is very important. The moment you just see a minus A, just know that you have to put the N intersection, and the one that is on this side, you put a complement. Okay, so let's say A, B, C. And the third identity. So another identity So where I'm using the letters, they can put a different letter but same scenario. You just need to understand the concept. So the third identity is where if we have a set being united with a universal set, it means that it is equal to a universal set. If a set is united with a universal set, it means that we are going to have a universal set. And then another identity it says that if we unite a set, if we intersect, this time it's intersection. If you intersect a set with a universal set, you are going to get the set itself. What do they mean? If you try to find the elements that are found between a set and the universal set, where every element of the set are found, you are going to get the set itself. And then D, so E, when you intersect a set with an empty set, I forgot to talk about this. So there is also an empty set is simply represented by this sign, this symbol, or it can also be represented by this, the traces that are just empty. But when you're dealing with simplifying and demobbing, you should normalize using this. So when you intersect a set with an empty set, you're still going to get an empty set. And then F says that if you unite a set with an empty set, a union of a set and an empty set, you are still going to get a set itself. So for the other identity, it says that if you intersect a set with a complement of itself, you are going to get an empty set. And then H, we are going to say if you unite a set with a complement of itself, you are going to get a universal set. So these are very important. We are going to be using them to solve questions. If you haven't understood, make sure that you go through them. Make sure that you rewind the video, you watch them all over and over again, because these concepts are like the backbone of this topic. What we are going to be using throughout the topic, throughout when you start solving the questions. So let's solve some questions from the tutorial sheet. These questions that you are seeing on the screen right now, these questions are the questions that they bring on the exam. It's on this concept, they don't go beyond this. So if you're able to solve all these questions, then you can't get any question wrong when it comes to proving and verifying De Morgan's law. Those questions are on question 5. So let's begin with the first question. So in order to prove this De Morgan's law, we are going to use what is called arbitrary method. Sometimes they even tell you to use arbitrary method. So using arbitrary method, we will need to show that this is a subset of this one, and this one is a subset of this one. So for the fact that they are subsets of each other, it means that they are equal. Okay, so now how do we do that? So we are going to pick any side. You can start with the left or the right, but we are going to start with the left hand side. You are going to say left hand side, and then you are going to assume that x is a member of this whole thing, this whole set. So you are going to say let x be a member of B intersected with C complement. So now, we're saying that X is a member of the complement of the intersection of B and C. So meaning that this X element is simply not a member of the intersection of B and C. So it can also be written as X is not a member of intersection of B and C. What does that mean? It means that this statement A and these statements are the same. So once you reach A now, you're going to expand this by multiplying through. So you're going to say X not a member of times this is going to be separated by what is inside here. So the moment you expand, N will no longer be written as N, it will be written as AND. So N is written as AND, and U is written as O. So the moment you expand through, where there is N, you put AND, where there is U, you put O. So let's say X not a member of, so we're going to say B. When you multiply this with this B, then you separated by what is inside. So meaning that we are going to have AND. Then if we multiply this with C, we are going to have X being not being a member of C. Okay, so now as you can see, so we're saying that X is not a member of B, right? So this can also be written as X is a member of complement of B, meaning it is a member of a set that is having elements that are not in B, meaning it is not a member of B. I'm pretty sure by now you understand the meaning of complement. If you don't, go and watch the introductory video that I've just recorded. We have explained the basics. So now, so this and this are one and the same. So where there is this, you can replace with this. That's what it means. This and this are one and the same. So the moment you change this to another form, it means that even the AND A is going to change. It is going to change to what? To the opposite of AND, which is O in our scenario. So where there is AND, you put O. And then even this one is going to be written in another form, but still meaning the same. So we are going to say X is a member of C. This and this are one and the same. So now, complement. So now we are going to reverse. Where there is O now, we are going to put N. This is going to look like this. It's going to look like this. We are going to put N here and complement. Okay, so now as you can see, we have something that is common on both sides. We have XA and XC. We can factorize that out. We're going to say X is a member of, we are going to remain with, we're supposed to have U. It is supposed to be U, as O represents U. So we are going to have B complement when we factorize this. B complement union, we're going to assume that they have been removed. So B union C complement. Okay, so meaning that we have this. C. So now by doing this, it means you have showed that this side is a subset of this side. So you are going to say you're going to say therefore B intersection C complement is a subset of B complement union C complement. So by just reaching A, actually this question comes with 5 marks, so by just reaching A you are going to get 2.5 marks. So now we have just showed this side, so now we also have to show this side. We have to show that it is a subset of this one, meaning we have to bring it to this form. We have to prove, meaning you have to simplify it, or we have to apply concepts that to lead us to leave this in this form, to look what is on the left hand side to appear like what is on the right hand side. That's the goal. So your goal should be to make it look like this eventually, like the way we did here. So now let us show the right hand side to the left hand side. Let me say left hand side to the right hand side. So now let us show now the right hand side to the left hand side. The moment we show that, it will mean now that we have proved that they are equal. That's when you're now going to get the 4 marks. Okay, so now let's apply the same concept. Let's assume we have an element X, which is the member of B complement U C. So this time we don't have a complement here, meaning no symbol will change here. The moment you just see a complement here, just know that the symbols are going to change. So we are just going to expand, and we are going to have this B complement union is going to be written as O, and then we multiply this with this, we are going to have X a member of C complement. Okay, so remember we are targeting to live in this format. So remember we are targeting to be left in this format, right? So now we are going to reverse this. It is now going to be reversed into the other format it can be written. Remember, this is also equal to this not being a member of B. They are one and the same. They will still give you the same results. The moment we change this, even this one here changes it to be and then even here we're going to do the same. We are going to write the same format, C complement, meaning that sorry, this one is going to cancel, ignore this. So now remember, and is represented by n, right? So this is going to be B, and then and you are going to put n, and then X not being a member of C. Now what's common here? This is common, right? You are going to factor it out, so we are going to remain with X not being a member of, imagine that it has been factored out, right? So we are going to remain with B intersected with C. Now remember, this can also be written like this. This is one and the same. If we represent it like this, they are still saying that X is not a member of all this. I mean, if we represent like this, it can also be written like this, where you make it being a member of B intersection of C, but this time it is being a complement. Yeah, so now this and this are one and the same, since our goal is to reach here. So now By just doing this, we have now earned the full 5 marks, meaning that we have showed that even the right hand side is equal to the left hand side. So you can even conclude. Before you conclude, make sure you show them that you need to show them that B, say therefore B complement of C, B complement united with C complement is a subset of intersection of B and C complement. So then now you're going to conclude that you're going to say since they are subsets of each other, it means they are equal. So since they are subsets of each other, it means they are equal. You can even say hence proved. So this is what is called arbitrary method. Okay, these statements doesn't matter as long as you've showed the two parts, as long as you've reached A and you've also showed that the left hand side is a subset of the right hand side. These statements you can just write to just make everything appear to be sensible. If you want, you can say since the left hand side and the right hand side are subsets of each other, it means they are equal and it's proved. They just want you to show these two parts. Okay, so if you have been told to show or prove, you use this method. If they say show or prove, use arbitrary method. But if you've been told to verify, you need to come up with your own values. You need to come up with your own sets. You need to come up with your own sets with including the universal set. Don't worry, I'm going to show you how to do it. So even for question B, you just do the same thing that I've done here. They are one and the same. Even question 2, to prove, you just need to show the same thing. Anyway, let's solve it. Let us solve it. So it is saying that we need to prove that this is equal to A. Okay, so remember, we are going to assume that the element X is a member of whatever we've been given. You can say left hand side to the right hand side. So now remember, there is a complement A, meaning that the symbol A is going to change. So you're going to say X is not a member of a complement. So you're now going to expand. You're going to multiply through. Okay, so again, remember, this can also be represented by, it can also be represented by like this. Meaning that if we multiply this with this, they are going to cancel. So we're just going to remain with this A. So meaning X being a member of A. So by doing this, it means that you can say therefore A complement is a subset of Okay, now this was the left hand side to the right hand side. So now let us now prove the right hand side to the left hand side, right hand side to the left hand side. Okay, so now we are going to get this A. We are going to assume. So here the key is that the way you prove this one, you are just going to reverse it when you want to prove the other side. That's like the basic knowledge when you are proving. So here we're like simply going to reverse the whole procedure for us to reach at this point, like the way we did here. So now we are going to assume that X is a member of A. Remember, this can also be written like this. This can also be written like this. It is one and the same, right? Since we want to reach to this point, okay, so now let's say we've been given to verify or show that this side is equal to this side. So verifying and showing are two different things. If you've been taught to show or prove, you have to use arbitrary method. That one where we're assuming the element X to be a member of whatever is given. That is arbitrary method. Now if you've been taught to verify, means they want you to formulate your own set, a universal set, and also to come up with the members of those sets. So you're going to use those sets, and then you're going to find the values using the sets that you're going to come up with. The value that you're going to find after you apply this should be equal to the value that you're going to find after you apply what is on the right hand side. Okay, so let's begin. So first of all, we're going to assume we have a universal set, which is having natural numbers starting from 1, 2, 3. Right now we are verifying. If we are taught to show, so you just have to do one thing. It's either you verify or just show. So whatever is simple for you, whatever that you've understood the most is what you should apply, unless you have been taught to only verify. Okay, so let's assume we have a universal set. 1, 2, 3, 4, 5, 6, 7, 8. Then we have set B. Let's say we have set B. We have set B having 1, 3, 5, and 6. And now we have set C. Let's say the set C is having 1, 2, 8, and let's put maybe 7. Just some random values. Okay, as you can see. So you're going to come up with your own sets, including a universal set. A universal set is a mandatory because we'll be working with complements, and where a complement is involved, a universal set is also involved. Okay, so now what are they saying right now? They're saying that, so let's begin with the left hand side. We're going to say left hand side to the right hand side, left hand side to the right hand side. So now you're going to get the left hand side. Let's write it. Remember, you're verifying. Okay, so now they want you to find the intersection of B and C, meaning the values that are found in B and C. What are those values? We have 1, 3 is not there, 5 is not there, 6 is not there, so we only have 1, right? So we only have 1. So So now they want you to find the complement of that set. Okay, so the easiest way to solve this is to come up with a Venn diagram. We are going to come up with the Venn diagram. So you're going to say this. So here we have 1, right? We have 1. This is let's say this is B and this is C. So now let's say we have 3, 5, 6, and we have 2, 8, 7. Okay, so what is between B and C that is found in both? It is here, right? Now they want you to find what is now not what is not in this set. What is not in this set, meaning whatever is outside A is what they are looking for. So what would that be? So similarly, if we were to use these, meaning that they want all the items apart from 1, meaning that we are simply going to choose the universal set. We are going to list all the members except 1, because 1 is what is in between B and C, and they don't want to list any of the items, any of the elements that are in the intersection of B and C. So whatever is outside, including the universal set, should be included except for 1 that is in between. So we are going to have the set like this. We're going to have 2, 3, 4, 5, 6, 7, and 8, right? Okay, so now according to this, so now we can say, we're going to say we're going to say B section C complement is equal to this, as you can see. So this is just the left hand side. Now let's look at the right hand side. Right hand side to the left hand side. So we are going to take this part. So they want us now to find the element that are in a set where we have B complement united with C complement. Okay, so meaning that, as you can see, we have B and C. This means that they want you to unite the set, the elements that are not found in B. What are those elements? Anything that is out here, right? It is not in B. They want you to list it. You are going to list it, and now unite it with whatever element is not in C. So this will still give us the same set, because it is still showing that we are not going to include 1. If you want, you can simply simplify this further by just reversing the De Morgan's law principle. By reversing this can be reversed like this, this can be reversed like this. Remember, this is going to change. See, we're still going to have the same thing. So basically they just want you to show them that it is still giving you the same set that it gave you at first. So you're just going to list it. You're going to say that B union C is equal to the same set uh, as you can see. So it will still give us the same set. By showing this, you have verified that the left hand side is equal to the right hand side, because if we plug our elements with our sets that we've come up with, it is still giving us the same answers. So you can say hence verified. Hence verified. Okay, so that is it. So in the next video, we're now going to solve some questions involving simplifying. So these are all the questions that they bring on De Morgan's law, like when it comes to proving, showing, and verifying. They don't go beyond this. So once you know how to solve this, you can never get any question wrong.